Hello, welcome. So, in the last episode, we talked about this data structure here. So I have some bad news. The bad news is this doesn't quite work the way that I described it. I actually had it backwards in my description. Might be a little tricky to explain why without doing it visually. So just one second. So this is actually backwards. The root node is over here, but it should actually be over here. And the reason for that is that when you're parsing, you parse the children first, and then eventually you figure out what the root node is. The root node will be the end of the file, basically, when you're parsing. So if we had it in this direction, we'd have to start at the end of the array and go that way. But then we don't know how big it will be as we're parsing, and there's a bunch of problems with this. What we could potentially do is just reverse the order of the memory after we're done to have it in this orientation, because then it makes navigating the data structure a little bit easier. Yeah, let's worry about that later and just flip this around. So then the root node will be over here, and we will start by filling it with children. So that's what we're going to do with that. Now, as you might be able to tell, I've actually had one go at recording this episode already, and let's just say that this is quite a lot of work to build a parser all of a sudden. Let's see if we can get this a little bit smaller amount of work. So this episode is mostly going to be building out this data structure a little bit better. So that's what this will mostly be about. So the big thing here is we're going to, well, actually, you know what? First, let's just do a little bit of cleanup here. One thing that was a big problem with the first go at trying to do this, and, I highly recommend that when you're writing software that you try things out, just fork a branch and try implementing it at least once before continuing, because then you'll know if you back into a corner somewhere, and quite often you do, and it's nice to kind of know about those and figure out how you can set up the original situation to work a lot better. And I find quite often the second or the third implementation of something is way better than the first go at it. So quite often you can really improve the quality of the code that you write just by trying it a couple times before you commit. It takes longer, yes, but the quality is much better, and you quite often have more reliable systems that you build. So in this case, this file is getting a little bit long. I mean, it's not too bad, but what I'd like to do is start doing a little bit of testing. Now, I generally shy away from unit tests. I tend to prefer more like integration level tests where I'm testing each module in isolation rather than each function, because I feel like the functions themselves are implementation details. It's the use cases that actually matter. So I tend to test use cases, and I tend to test at a higher level, like an integration of one or maybe a few modules. And then, of course, I have end-to-end tests. And I tend to shy away from unit tests because I find that they quite often break when you try and refactor things. And I don't want to have a lot of friction on refactoring, because refactoring is extremely important to making sure that the system works. So that's out of the way. Let's do some testing. I went online, and I'm a huge fan of single file header libraries, and I found one called UTTest. let's see. Yeah, this doesn't really tell you anything, but this is where you can find it. It's just called UTTest. I tried another one. It was Clove Test, I think, or Clove unit. I forget. Anyway, it segfaulted on me, and I couldn't readily figure out why it was segfaulting. So I was like, well, that doesn't bode well for this library. This one's a little bit simpler, and it seems to not segfault on me. So I have a test file. This one just has the UTest main in it. So this will become the binary that runs. And then in here, this is kind of an example of what the syntax looks like for writing tests. This would be like just a group name. And then this is the name of the unit test itself. And then there's a bunch of asserts that you can do in order to make the testing a little bit better. I kind of wish you could just have plain C functions, and but the macro kind of registers the function with the test runner and stuff like that. So okay, that's fine. So yeah, so now we've got a way that we can run some tests. One of the things I like to do is I like to write tests that kind of have this structure. So, so I like to have tests that kind of have this structure where you've got some sort of name for the test case itself. That just helps you figure out which test case is failing when it does fail. And then you have the source code that goes into it. And then you've got some sort of result that you're testing. And this is quite often just a pretty printed result, say, of the abstract syntax tree or the tokens that get parsed or whatever the case may be. So I tend to go from the input as far down the pipeline as I can towards some output of some sort. Now, then what I would do is just set up some tables with the results. So I'd have just like so yeah, something like this essentially would be test cases for a parser. So that involves actually building up these strings from the AST essentially. So then this would be the AST types. This would be the token type, etc., etc. So, and I guess literal might need, no, it's fine. Okay, so that's kind of the thing that I would like to do. In C, this is not straightforward to do. In Go, it's easy because you got a garbage collector. You just make a bunch of garbage and build these strings, right? In C, you need some sort of buffer that you can write into in order to get these strings. And I guess a small buffer would probably work just fine. Yeah. But then you might also want to, if you have a larger program, you might want to dump this to a file or something like that. So it'd be nice to have some flexibility there. So let's see what we can come up with. For now, well, I guess it compiles, right? Yeah, there's no errors, so I'll leave this for now. So first things first, let's pull some of this out into a header file, because that'll make it easier to share with tests. So let's see. Now, the kind of standard C way, or kind of like the way of building C programs that doesn't require a huge amount of work, is just to put everything in one great big header file and just use that everywhere. The downside to that is that if that header file changes, everything has to recompile, but it's C. Recompiling doesn't take very much time at all. And if it does take significant time, there's things like TCC where, it's much faster. And so you can use TCC while you're developing and then switch to like GCC or LLVM later. So it's not really that big of a deal. So I think I'm just going to put everything in one big header file just for ease sake. But in order to navigate one giant header file, it becomes a lot easier if you can just say that there's regions. So you can and region it. Yeah, what's it say? Oh, it's just my spell checker is spell checking this for some reason, and it's not supposed to. That's going to get really annoying fast. So I'm going to try and fix that. Okay, I think I figured it out. I think it thinks this is a C++ file instead of C, and so I was using the wrong settings. Anyway, so we need to pull in this stuff. I might as well pull in this. Now, what the region allows us to do is just fold this like that. That's all it does as far as I know, but that's nice. We can just collapse things that we're not working on at the moment. So I need that there. And I know I'm going to need standard bool eventually, but I'll leave it until I need it. Now this one's static, so we don't do that one. Okay. Now there's a bug in this, in that it's not abundantly obvious that there's no null terminator on this. Is this used anywhere? It is. And I think I might actually be using it wrong. No, A2I will work correctly, because it'll just stop parsing once it gets to some non-number. So I think it was more or less a fluke. So I might want to rename this to no null terminator. And then, yeah, string, and then pass in a that's a good assert. I'll take it. I think that's what I want. And then if len, then it becomes the max size. And then we do len here. It'd be nice if it had the parameters on there. Okay, so string copy. I mean, it doesn't comply, or doesn't, oh yeah, yeah. That would be why it's not giving us the docs. There we go. Where was I? Here we are. Yeah, so destination. Destination source length. Yeah. What is this? Okay, so this is a much safer way of doing it, but it does allocate, or no, it's not allocating. It's relying on a buffer that you pass in order to avoid the allocation, which is fine, I think. And it would be kind of nice to have our own string types, but then it gets really complicated, and anyone that knows C may not understand the basically standard library replacement that I build. If I weren't making videos, I would probably replace the standard library with some nice things from other languages. You can make a nice string type and vector equivalent and things like that, and it saves you some time. But just passing around buffers to things that could potentially allocate is fine for now. What else? Might be nice to pass out the new size, so we could have int star length. Does this return? Oh well. Let's just call it size, and then like that. And then you can just pass null if you don't care. But that just allows you to append a bunch of tokens to a string, one after the other, without having to do strlen each time. Just a little bit faster. So I suppose that's good. So this one will be faster if you're gonna get the length like this and copy it into a buffer or something like that. This one is safer in general, so you'd want to use this one most of the time. So let's copy these into here. All right, so we've got our tokenizer. What I tend to like to do is just write documentation in here about what everything does. I'm not going to do that right now, but I may do that a little later because things are still kind of in flux. I like to write the documentation once things are kind of stable and not changing very much, because there's still a chance that, you know, this tokenizer won't work and we need to significantly rewrite it. So, and then we've got this, and we might as well start putting this into the H file, I think. Oh, speaking of which, we need to delete some things here and include, there we go. And then start just putting this into the H file. So I'm going to collapse this for now because we're not looking at the tokenizer. So there's a few things to talk about this data structure. The first thing to mention is this is kind of an immutable data structure in that because of this num nodes that's keeping track of, you know, how many children there are and how to find all of the children, there's not really a efficient way to modify the AST when it's built this way. Now, for this particular project, I think that'll be fine to have a static AST because I'm planning on converting it into an intermediate representation almost immediately. So this tree structure is only going to last as long as it takes to do some symbol lookup and type checking, and then it's going straight into an IR, and the IR will be mutable and able to be transformed and changed. So I think that's fine. But if you were going to stick with just an abstract syntax tree and you had some like syntactic sugar that you needed to expand and things like that, I would not recommend this structure. I would recommend having a separate list of children. So then you would have like node ID star children, and then num children, I guess, put it down here like that. And then you need a node ID, which I'll need anyway. This is just like a thing that you can return saying that it doesn't exist. This helps when you're iterating over children, for example. You can tell it there's no more children. So yeah, this would be the structure that I would recommend then, and then you don't need this. And you can fill that in with something else. I don't know what else would be 24 bits. Well, actually, no, I know exactly what it would be. So then you would have num children. Yeah, so then you would have probably no. Something like this. And you could move the token out if you wanted to. But if you did move the token out, I would recommend making the node type a little bit more specific. So then instead of binary, I would have add, sub, etc., and kind of make this more fine-grained rather than general. That's what I would do or recommend. And this structure is probably a little bit easier to understand. So yeah, then you would have like an array of children that is just node IDs. And this would point to the first child in this array. And then you would have the number of children after that. And this could be a smaller size potentially. I mean, with an AST, the largest child is going to be the root node, and it may have many, many children. So that's why I do this. So that's another way of doing the abstract syntax tree. We're not going to do that because I kind of want to explore this way of doing it. So I'm just going to undo everything here. Okay, so we need to have some way of pretty printing this and some way of creating this. So, and I'm going to put in the tokenizer here too. I'm going to put this down here. Could copy the whole thing in here. That'd probably be faster. I'm going to do it. Yeah. Yeah. Instead of this, I'm going to do this. AST init, AST free. I'm going to give it like that. And what else do we need? I guess we need a way to build nodes. So what I'd like to do is type I think maybe don't need that. Okay. So with this node context, what we can do is we can do est start node, and instead of void, actually, it's going to return node ctx. And we've got token, sure. And what else do we need? Oh, node type, of course. Like that. Okay. And then like that. So then this would pick up the context that we need in order to start creating a node. And it kind of just puts a placeholder there, and then end node will finalize it, basically. So in order to calculate the number of this parameter here, the number of subnodes, I guess it is. And this is kind of confusing naming. So num subnodes, it's not the number of children, it's the total number of nodes under it, sort of, so to speak. So I guess I could remove num. I could just call this subnodes like that, or total subnodes, or yeah, I'll just call it subnodes. So that's for creation, and then we've got iteration, but we'll get there once we're working on the dump code, because we'll figure out what we need at that point. So I think this is enough to get started. So let's work on that. What's wrong? Why does it not like it? Okay. Potentially I could move all of this out into a separate file now. That might be nice. Let's just paste this in here and then copy this over to somewhere else. Yeah, I'm trying out a different one. I want to say Codium rather than Copilot. I'm not sure Codium is better. In some ways it is. Copilot seems to be a little bit smarter in other ways, but anyway. Okay, that seems to have worked. All right. And do we need all of these? Probably. Okay, let's just leave that. So Ngazi here. Well, first of all, we need to fix our make file. Okay, this probably needs a cleanup too. I can factor out these lists here. Do I do that now or later? Probably later. Once we have 3 files, then it becomes annoying. Which will be soon, actually. Okay, so we've got our... so how are we going to test this? We need to kind of drive this with some sort of test, I think. Could probably drive it with this, sort of, but not quite. No, let's just keep it lowercase. Well, no, let's do that. And then, well, let's see if it errors. Okay, let's include... What's the problem? Okay, it's just taking a while to reparse everything. Okay, no, okay. I want to call that. Okay. let's just say this is 42. Well, sometimes we need some sort of buffer. Yeah, sure. And we need a way of getting the root node. Basically, and then free it. Okay, I think that's what we need. In the make file, we need these as well. We need to put this in a different file, so in order to test it. Okay, so we're going to end up doing this right away anyway. Can I hit rename on this? Network. And I'll need to rename all of these at some point as well. Do that later. Is that working? No, they don't. Okay, hopefully it'll sort itself out. Okay, we got linker errors. Oh, yeah, of course. Let's just do this. I think. Oh, what's wrong? Okay. Yes. Of course. Start node. What's wrong with this? Oh, yeah. So it'd be nice if it actually read the type. It would make it more useful, but it does not. So node context is node and number of nodes. So we need to allocate a node. I'm going to just split frame this a little bit. Let's, so we've got our AST right here. Let's just kind of do this. There's our AST. It would be nice to get rid of this bar so there's more screen real estate. That bar, it's not, I never look at this. Wonder how to do that. I don't know. Anyway, so we've got a capacity here, and we need get rid of that. Okay, what are we doing? And then set the tokenizer. We do. I'm just looking at the time, and we're running out of time. Well, that's how it kind of goes. You start getting into programming, and time just gets away from you. Let me try and implement some of these things. I don't think we're going to get this test passing, but we could simplify the test maybe to something that just tests start node and end node maybe. Yeah, let's do that. So start node would be, well, we need to allocate. So if num nodes is equal to that's basically what we want. We also want to reallocate types. Value type needs to be uint32t for now, until I figure out what it actually is. Okay, why is it complaining? Capacity is right here. C and its language servers. Let's try just force reset. Did that fix it? It seems to. Yeah. Okay. That's good, but I don't like doing this. It's a little confusing. I'm used to Go where this is, to increment, this would be a statement, not an expression. It's just a little bit more clear to separate these into two lines. You know exactly what it's doing. Whereas you can do like a pre-increment and a post-increment and what's the difference and all of the rest. In this case, it doesn't matter. It's the same thing. Okay. I might try switching back to Copilot to see if it handles some of this split between a header file and a C file better, because yeah, Codium is really not working very well in this arrangement. It works a lot better if everything's in one big file, but that's not always going to be the case, especially with C. So okay, so with ending the node, all we do is and one thing that we might want is just a faster way to do both of these at once. So void add, it's just going to be this. And then basically we copy this over here. Basically all in one. All right. Yeah, in order to do dump, we need a bit more time, I think, than what we have. We're running a little long in the tooth, so let's modify our test. This is kind of aspirational. So we can't dump yet. Let's just comment this out. Let's and then does this work? Does it like it? Node star, nodes 0. Doesn't seem like it likes it. Okay, let's just assert these things separately. And this is exactly what I don't like to do. This should be literal. And again, it hasn't this. Yeah, the language server is all busted. I might investigate to see if there's a better language server for C, because this is kind of ridiculous. Okay, what's wrong? Struct token. You can't compare the struct token. Really? Really? Whatever. Let's just see if this compiles. Oh, this is a nightmare. All right. Really? Oh. Seriously? Unused variable buffer. All right. All right. It passes so far. We haven't done a whole heck of a lot, but I think we need to continue this next time. Let's see. So today we separated out the C files mainly, talked a little bit about data structures and C programming, and the best way to do things. Got a test framework working, which is good. Our tests are too low level right now, but we need to get dumping working, which we'll do next time, with the goal to get to tests that look more like this, which would be great. Yeah, so I think this is a good start. So one thing that I've done is set up GitHub sponsors, Patreon. I have a Ko-fi link. There's also super thanks on YouTube itself. I might set up YouTube members. All of this is just to try and recoup a little bit of my costs. I'll put it this way. As of recording this video, I am not employed. So I am just living off of savings. If I can make a bit of income, then my savings will last a little bit longer. The other thing that I would like to say is, I'm not expecting to make a lot of money off of making these videos. What I really want to do is help out the community of people who like to build CPUs. And if you look at the subscriber count on my channel right now, it's not very high. It's like 4,000. I'm not expecting to get like millions of subscribers or anything like that. That would be, if it happens, then amazing, but I don't think it's going to happen. I'm not in any delusion that I would make a significant amount of money off of this so that I can, not look for work in the future. Big thing is, like, there's a community of people that like to build CPUs and tinker with this stuff and really loves this low level, like, programming and stuff like that. I'd like to make content for that community, and if you feel like you want to support that endeavor, feel free to, use the service that you like the best. I would prefer that you would use Ko-fi because it has the lowest fees of all of the options, but I gave you lots of options in case you prefer something else and you don't mind the higher fees. So yeah, I mean, it's totally up to you. I'm not going to tell you what to do. I appreciate anything you can do to help. But absolutely no pressure. And I'm definitely not going to tell you what to do. So yeah, maybe I'll talk more about that maybe in a separate video or something like that. But yeah, I just want to make content. I just want to do stuff. And if I can recoup some of my costs, then awesome. If not, c'est la vie. It is what it is. I'm still excited about this and want to do it anyway. So yeah. Thank you very much for watching. I really appreciate it. If you want to show your appreciation as well, it's up to you. You can do what you like. Yeah. So I hope you have a great day.